Okay, for what we have in number 28, we have an equation that is not a Bernoulli equation, it's not a homogeneous equation, and also it is an equation, okay, that is not separable. And but if you notice, we have with the variable terms, okay, so we have in y, you have alongside the derivative, we have the e to the y portion, and we have to the right, we have e to the y contained in parentheses. And now, so we have y is appearing only in the combinations of what we have with e to the y, and the derivative of e to the y will go to itself. And we have a pattern that we can create upon the use of v substitution. And if we let v be equal to e to the y, and we take the first order derivative with respect to x, okay, so we have dv over dx is equal to e to the y dy over dx. And for what we have in this particular case, all right, so we have v is equal to e to the 2y, and again dv over dx is equal to 2 times e to the 2y dy over dx. And looking at what we have now, so if I replace e to the y dy over dx with dv over dx, I'm going to have in the rewrite, I'm going to have x times dv over dx is equal to 2 times the quantity, and notice we have v in lieu of e to the y, and we have plus x cubed times e to the 2x. And if I go ahead and distribute the terms on the right hand side, so right now we got x dv over dx is equal to 2v plus 2x cubed times e to the 2x. And I can go ahead and divide the equation by x, okay, to get what I have in terms of where we have no variable coefficient or anything other than 1 in front of the derivative. Okay, so you have dv over dx is equal to 2 over x times v plus 2x squared times e to the 2x. And if you notice, okay, we're going to have first order linear equation for v. So we have just getting the v terms on the left hand side, so moving the 2 over x times v. So I have dv over dx minus 2 over x times v is equal to 2x squared times e to the 2x. And here we have in the variable v, okay, I have in the pathway to creating the integrating factor. Now I got rho of x is equal to negative 2 over x. And for the integrating factor, so I'm going to have e to the integral of rho of x dx. So we have e to the integral of negative 2 over x dx. And ultimately, okay, you have e to the negative 2 times the natural logarithm of x, or x to the negative 2 or 1 over x squared. And using this to multiply, again, you have dv over dx minus 2 over x times v, and 2x squared over x squared, that's going to leave us with 2, and then we have times e to the 2x, and the left-hand side, the product of the left-hand side and the integrating factor, that is going to be the product rule expansion of taking the derivative nx. Once again, I'm multiplying the integrating factor by the dependent variable which we have at the moment at v. And we have again is equal to 2e to the 2x. And taking the integral with respect to x on both sides, so we have v over x squared is equal to the integral of 2 times e to the 2x dx. And again we have v over x squared is equal to what is going to be e to the 2x followed by the constant. And we have that v is equal to x squared times e to the 2x plus cx squared. And again, we had earlier that v represented e to the y. And if I take the natural logarithm of both sides, I'm going to end up with y is equal to the natural logarithm of the quantity of x squared times e to the 2x plus cx squared. Okay, for what we have in the case of number 30, and this problem is rather tricky. It's not a Bernoulli equation, it is not a homogeneous equation, and it is one of those that requires rather tricky v substitution. And for what we have in this particular problem, okay, so we have the quantity of x plus e to the y, dy over dx is equal to x times e to the negative y minus 1, and just rewriting what I have here. Okay, so I got, and expressing in positive exponential terms, okay, so I have x over e to the y minus 1, and let's say if I just consolidate as a single ratio, so I'm going to have with e to the y in the denominator, I can just say that x over e to the y minus 1 is going to be equal to x minus e to the y all over e to the y. And looking at what we have in isolating the derivative, so I'm going to divide by the quantity of x plus e to the y. So we're going to have in the rewrite x minus e to the y all over e to the y times the quantity of x plus e to the y. And just for the v substitution, okay, and I'm just going to let v be equal to x plus e to the y. Now if I express what I have here in terms of e to the y, so I have e to the y is going to be equal to v minus x. And if I were to take the natural logarithm of both sides, so I have the natural logarithm of e to the y is equal to the natural logarithm the difference between v and x. And guess what? Okay, so you're going to have that y is equal to the natural logarithm of the quantity of v minus x. Right. So I'm going to take the derivative with respect to x. So I'm going to have dy over dx is equal to the derivative with respect to x of the natural logarithm of the quantity of v minus x. So we have, in setting things up, so we have dy over dx is equal to, first of all, okay, for the v portion, we'll say that we have d over dv times the natural logarithm of the quantity of v minus x and we have dv over dx, and we have plus d over dx of the natural logarithm of the quantity of v minus x. And for what we have in the follow through, okay, so we have dy over dx is equal to, now we have d over dv, the natural logarithm of v minus x. So I'll be taking the derivative on the natural logarithm side. So I have the reciprocal of v minus x, and just taking like a little bit of a chain rule expansion. So we have the derivative with respect to v minus x, and again I have dv over dx, and we have plus, okay, now with respect to x, so I'm going to take the reciprocal of v minus x, and I'm going to take the derivative with respect to x of v minus x. Now I have a negative x term, so the derivative here goes to -1. But now for v minus x, taking the derivative in v, okay, derivative with respect to v of v goes to 1. Negative x, it is negligible, so we got a positive 1. And so gathering together what we have here, so if you notice it got what's going to be 1 over v minus x times 1 dv over dx, and 1 over v minus x times -1. So if I just write this in factored form, so I'm going to have dy over dx, and I'm just going to factor out the reciprocal of v minus x. So I have, first of all, I have dv over dx, and followed by -1. And looking at what we have in the original equation, so I'm going to take in the rewrite. So we have dy over dx is equal to, and we have x minus e to the y, and guess what? I have e to the y at v minus x. So I'm going to have x minus the quantity of v minus x. Now we have all over. And we have e to the y again. We have v minus x. And we have times, okay, the quantity. Okay, so we have x plus, and e to the y, we have v minus x. If you notice, we're going to have some cancellations. Okay, so you have x's will cancel out. So we have dy over dx is going to be equal to, notice we have x minus negative x, so that will be 2x minus v, and that is going to be all over v times the quantity of v minus x. And looking at setting things up, okay, so we have these two expressions, okay, for dy over dx, and if I set what I have equal to each other, so I got 1 over v minus x times the quantity of dv over dx minus 1 again we have is equal to 2x minus v all over v times the quantity of v minus x, and I can multiply both sides by v minus x. So this is going to come down to dv over dx minus 1 is equal to 2x over v, and guess what, negative v over v is negative 1, and lo and behold, okay, we have another cancellation, so we now have dv over dx is equal to 2x over v, and now I can separate the variables, so I have v dv is equal to 2x dx, integrating over both sides, so I'm going to have 1/2 of v squared is equal to x squared followed by the constant, and isolating v squared, so I have v squared is equal to 2x squared, and you can say plus c or 2c, I'm just going to use the letter alpha. And having set up what we have, okay, for v, okay, so again I had v established as x plus e to the y. And squaring, so I'm going to have x squared, and what is going to be plus 2x times e to the y plus e to the 2y is equal to 2x squared plus alpha, and if I were to take 2x squared away from both sides and I isolate alpha, you can say we have alpha is going to be negative x squared plus 2x e to the y plus e to the 2y. And another way you can express this, okay, if you were to switch the signs, because you have what are referred to as constants absorbing, and you could like divide by negative 1 and say something, and we'll just call this beta, like alpha divided by negative 1 or multiplied by negative 1. And we say we have x squared minus 2x e to the y minus e raised to the 2y.